Hello again, it's your favorite geometry teacher, Mr. Johnson. This is the notes for section 7.4, talking about special right triangles. Meaning they're just something specific, a specific kind of right triangle. And you can see the two names right here, 45, 45, 90, and 30, 60, 90. These are all degree measurements. So what we're talking about is if the angles are those in a right triangle, then the side lengths have some special properties. Whoops. Okay, take a second, copy down these notes, the picture, all this stuff right here. Okay, so the first kind of special triangle that we'll talk about is called a 45, 45, 90. The name comes from just the three angle measurements. All right, you have a right triangle, so you got the 190-degree angle, and then the other two angles, they are equal to each other, which makes them be 45 degrees. That also, because those two angles are equal, makes this an isosceles triangle. Those two legs of the right triangle are going to be congruent to each other. Now, what you have is a ratio of sides, okay, in a 45, 45, 90 triangle. When you have that triangle with those three angle measurements, the relationship between the sides is what I just circled there, along with the two legs being equal to each other. Okay, so legs congruent. Okay, those are your two properties for a 45, 45, 90 triangle. Now, the proof of that comes from this. We have a right triangle. We have two angles that are equal there. So that forces these two sides to be the same. So we're looking at, because these two angles are equal, that forces that to be a 45-degree and a 45-degree angle. So I'm just going to name the hypotenuse h for obvious reasons, and just do Pythagorean theorem. I want to know what's the connection between x, one of the side lengths of the legs, and the hypotenuse h. So Pythagorean theorem. We have a right triangle, so Pythagorean theorem always works. X squared plus x squared will equal the length of the hypotenuse squared. Okay, x squared plus x squared is 2x squared, which still equals h squared. Now again, what I'm looking for is how does h and x relate to each other? So I'm going to solve for h, which means take the square root of both sides. That leaves us with h. And again, normally positive and negative from the square root of both sides, but we're dealing with side lengths, so I'm just looking at the positive answers. This is 2 times x squared, so I'm going to separate this. Square root of 2 times square root of x squared. So h equals the square root of 2 multiplied by the square root of x squared is just x. And this is our relationship. I'm going to rewrite it a little bit. H, which is the hypotenuse, that equals x, which is a length of one of the legs, and they're both the same length, multiplied by the square root of 2. And so there's that relationship. Didn't use any numbers as far as the side lengths. It just always is that way. So anytime you have a triangle, right triangle, with the other two angles being equal, 45 degrees, you're going to have these two properties. All right, so let's try an example, or 4. It says find the value of x, write your answer in the simplest radical form. Okay, so in example 1, we have a 45, 45, 90 triangle. You always got to make sure of what type of triangle you're dealing with. It makes the other leg 6, and now we're looking for the hypotenuse. It's not really an equation, it's just x equals the length of the leg multiplied by square root 2. Simplest radical form. In example number 2, and I hope you've hit pause and are trying these on your own. In example number 2, x is the hypotenuse. So to get the hypotenuse, you take the length of one of the legs and multiply it by the square root of 2. Now, the square root of 2 times the square root of 2 is just 2. All right, you could do this in a couple of different ways, but it could become the square root of 2 times 2, which is the square root of 4, which is 2. So that makes x equal to 18. In example 4, to get x, what we're looking at, we don't know if it's a 45, 45, 90 triangle, sort of, but what you do have is those two angles are equal, which forces, those two sides, the 12s, they're equal, which forces those two base angles to be equal because of the definition of an isosceles triangle, which makes, because of that right angle, makes these 45s. So we do have a 45, 45, 90 triangle. Always got to make sure of that. The 12 is the length of the leg, so x being the hypotenuse is 12 times the square root of 2. Simple as that. In the last example, number 5, those two legs are both x, forcing those to be the same, 45 degrees, same thing what we just did. Now, you take the length of the leg and you multiply it by square root 2, that is giving you the hypotenuse. The question is now solve for x. So, solving for x, we've got to divide by square root of 2. All right. Technically, this is okay. There are a couple of camps in the world of mathematics that say this is not a proper number. You should never have a square root of a number in the denominator. So to take care of that, what you can do is multiply top and bottom by that radical that is in the denominator. So 8 times the square root of 2 is just 8 square root 2 over square root of 2 times square root of 2 is 2. 8 divided by 2, the common factors, that gives us 4 times the square root of 2. That's the answer. That's the way your answer should be. All right, that is it for 45, 45, 90 triangles. Fairly basic. Again, you just got to make sure you're dealing with the proper angle measurements, which gives you these ratios of sides. The next video, we'll talk about 30, 60, 90s. Enjoy.